Hey guys, welcome back. Sorry we took so long. Kind of had a slight equipment malfunction, but those are the breaks, unfortunately,
Right, you
sometimes.
know.
So we're back with experiment number 2. This experiment's going to be kind of a little more basic than what the last
Right.
experiment was, but
But
you
probably a lot cooler, I guess you could say.
actually, yeah, it is a whole lot cooler.
Yeah.
So we're going to do a little bit of math for you, but you'll see that in your lab manuals. For the most part, though, this is going to be a pretty simple, basic, straightforward lab
Yeah.
with really cool, really quick results. And this is something Aspen came up with, which wound up being a really just when it worked and we were surprised, we
Oh
were
yeah.
like, yeah, so we knew we had to do this for y'all guys because we knew that y'all'd wind up enjoying this one.
Oh yeah.
So without further ado, this one's all on Aspen right here.
Right, for sure. Thanks, Brandon. So as you can see, our experiment 2 title is Sound to Light and Back Again. Okay. So the theory of it really is putting in a audio input, and what I mean by that is you can put in either like a music input, something like that, or something that has a sinusoid, a wave function to it, right? An input. And what's going to happen is we're going to use a LED light to pretty much transfer sound into a output speaker, right? And I will draw the circuit on the board for you in a second. We'll come back to that. But it is real simple. I'm going to get into full detail about how it actually works on a molecular level, atomic level. But pretty much what it is that you can actually capture energy from light, okay, using a certain material called a solar cell, which is this little thing right here. Okay, we'll really get close up later. And actually use the energy from electrons captured with that little panel into electric current, okay, which will then have an output from our speaker, and you will hear, what's being transferred. Okay, so pretty cool stuff. We'll come right back to you. We'll have the circuit drawn on the board, and then we'll explain a little bit further how it works, and then of course how to set it up on your IEEE education module. Okay, so we'll be right back, guys.
Right back. We're not going anywhere.
Right.
We're going to be right here.
All right. All right, guys. So welcome back. As you can see here, right behind us, Brandon. This right here is our circuit. So just like I said earlier, pretty simple stuff here. I will walk through it with you, the theory behind it and the idea and how it will actually operate. And then we'll go over to our education module and see how it actually looks on the circuit board, right? Okay, so, Brandon, what's wrong?
Nothing.
Okay, good. So we're going to start off with, of course, our voltage source here. We actually have 2 this time around. I will explain what each one does. So the first one right here that Brandon's pointing at, that is our DC voltage, okay? The value is 9 volts. We're actually going to use a 9-volt battery, okay? In this experiment here. For simple reasons, it works a lot better with the experiment using a separate DC source than trying to use the same source on the education module. So that's what we're doing today here. So in series, okay, right above it, right next to it, is our function generator. Okay, like I said earlier, you can use any type of sinusoid input for this to hear, a sound. Our sound is going to be straight from our function generator from the education model itself. And you're actually going to get to play around with this, with the amplitude and the frequency of it, to hear different sounds, which is going to be pretty cool in the end, okay, of it. And based off of how much high-pitched noises you can take, you can go all the way up to the maximum amount of frequency, okay?
And one thing to consider, though, right quick, while we are in a good spot,
of course,
is this is not going to be very loud.
right.
So once everything's in place, once your circuit's built, you're really going to have to put that speaker next to your head and really kind of crank it up into the kilohertz range to really hear anything coming out of that speaker. So if you don't hear anything at the lower frequencies, don't panic.
Right.
Put it close to your ear and then crank it up louder, because that's more than likely what's going on.
Of course. Good info, man. Appreciate it. Next, after the function generator, we have our resistor right here, our resistance. It's going to be 400 ohms. We do that to limit our our current and our voltage going into our LED, our light. We don't want to burn up our light. Okay, there's certain specs for our light that it can handle only so much. Okay, so with this, we're limiting definitely the amount of power that's going to our light. So we don't want to pop it or make it explode or whatnot, because that's not safe. Okay. And Brandon said earlier that the output won't be so loud. That is because you are actually sending energy through a light source, and there is a lot of loss in the light source here, coming from this circuit, going to our solar cell here. So that's why it's going to be kind of hard to hear, but you can still hear it nonetheless. Okay. So this right here, our LED is our light that we're going to be using. It's going to be a high intensity white light here, and how this is going to work is, like I said earlier, we're going to the light is going to emit what's called photons, okay, which are particles that are energized throughout the circuit. And what's real cool is that how the solar cell is going to work with this LED light diode is that once the photons actually hits the surface of the solar cell, the materials in the solar cell actually splits the electrons from the photons, right? So it means that all of the energy is going, well, most of it anyway, is going actually into our solar panel here, our solar cell, and actually creating a current. Okay, that's where we're going to have our current and our voltage being created right here. Okay, just based off of energy hitting a certain material, and it's actually creating a voltage, which is pretty cool. Okay, and then from that, our speaker at the end here is connected to our solar cell, which is also carrying our signal from our function generator. Okay, light can carry information, which is awesome. Actually, it's a pretty cool concept to think about. Any type of data here, which we have is our function generator. That signal is being carried through the light to our solar cell, and then we're going to hear output from our speaker. Okay, pretty cool stuff. Like I said, you only have 1, 2, 3, 4, 5, 6 components in this whole circuit. Okay, so it's not going to be that hard to construct on the box, but again, very cool stuff, and I can't wait to show you guys how it works, and hopefully you guys have a lot of fun with it. Okay? You want to add anything, Brandon?
Yeah, actually I do.
Of course.
So one of the things, yeah, of course, one of the reasons why we've got 2 of these in series is I want to give you real quick why we have 2 power supplies in series, because essentially this acts as a power supply. This is power, believe it or not. This is energy that's being used. So in theory, just an ideal diode operates at 0.7 volts. 0.7 volts. So if our voltage dips below 0.7, the LED stops functioning. So what happens is our DC voltage here in the circuit gives us a constant DC voltage of 9 volts, at least up into here. You do get a voltage drop. We can calculate that. That's not a problem. The essential portion of it is it gives us a constant steady voltage that keeps the LED running. Our function generator adds to that by doing this. However, since we have this base voltage right here, we essentially lose the negative portion up to non-zero from that, and so we're left with this. So our LED essentially transmits these peaks, and the solar cell will actually be able to detect the frequency by how many photons are coming out during those fluctuations. We can actually make the LED flicker the way we want it to, but in order to hear anything, we're going to have to reach a frequency where you're not going to be able to see it flicker. Right. Human eye can only see up to 30 hertz, which is why movies are filmed at 32 frames per second. So essentially, this is how it's going to work. So we're going to get relined here. We're going to zoom in on the trainer box.
Here, and then we'll show you how to construct it.
Yep.
Okay.
All right, guys. Again, we shall, in the words of Arnold Schwarzenegger, We'll be back.
Okay, guys, so welcome back. As you can see here, we're zoomed in onto our box here. So you might see a lot going on right now. Don't worry. This first half right here, don't worry about this part of the circuit right here. This is for experiment 3, actually, CP later on. So actually, we're going to worry about this bottom half of our board right here, okay? Now you can see here, I already have a few components actually in here, but I'll explain every component that we need for this experiment, and then we'll start working with it, okay? So the first off that we do need is our DC source, which is right, show you right here. Is right here with our 9-volt battery, okay? This is what we're using for our DC voltage source, like we said earlier, 9 volts. Then next in series with that is actually our function generator, which actually is going to be connected right here. This is our positive side of our function generator right here. Okay, so this black, the black now right here. This is what we'll be using as well as a ground. It's pronounced GND. This is the abbreviation version of it. This is going to be our ground to make sure your circuits are always grounded, so that way first they work and that you don't cause any danger to yourself. Okay. These right here are our resistors. So what we did was here is that we do require 400 ohms of resistance, right? Well, we don't have a 400 ohm resistor available actually. So what we did is to equal be as close as possible to 400 ohms is that we put 4 100 ohm resistors in series here. Okay, and if you remember back to our older video, when the resistors are in series, you just add up the resistances all together. So 100 plus 100 plus another is 400, right? Makes sense, okay? And then lastly, well not lastly, but for this first part, this is our LED right here. You can see, not nothing too fancy, but you can do a lot with this, and you will see this turn on. This is going to be a bright light, and this will be using to transfer our audio. Okay. So I want to get started here. We want to actually hook up our positive DC source to our negative side of our function generator. So what Brandon here hooked up the red, which is the positive to our DC, to the ground, which is our negative of our function generator. Okay. And then what we're going to do next is actually hook up our positive to our function generator in series with our resistance. Okay, so we're actually on the same row here. Okay, which allows you connect stuff in series, right? Then what we have here, we have our, like I said again, our resistors in series. So it's connected, on the same row, and then you actually move it. Connect the same row, then each resistor meets up, okay, to the next one, to each row. And then what we want here is to put our LED actually in series with our resistor here. So what I'm going to do is, actually you see, there's two sides of the LED. One's a little bit longer than the other, okay. Like you see, one side is a little bit longer than the other. We're going to put our longer side, okay, on right next to this pin, on the same row, right here, and then just connect the shorter side. Two rows down. Okay, just like so. Okay. So after that, what's going to happen is that we want to connect that back to our ground, which means we're going to hook up our negative side of our DC source in series with our LED light, and now you see the light is on. Okay, shouldn't be hot. You can touch it if you want to, right? I'm going to angle it down just a little bit, angle it towards this direction, just so it has a direction to shine onto the solar cell. Okay. So now for our second half of the experiment, you see we have our solar cell and our speaker. Okay, right here currently. So what's going to happen is we want to actually set up our solar cell in series with our speaker. So how we're going to do that is that we're going to hook up negative part here to one side of the speaker. Then actually take another part. And wrapping wires is not hard. You might want to ask your instructor or your teacher that's with you to help you with this. But it's just literally wrapping the wire around the pin here. Okay. So we have our light on, our solar cell connected to our speaker. Okay. Now, last thing we need to do is turn our box on. There we go. Okay. Make sure the box is always off when you're connecting components. And so make sure that your first top knob here is actually on the sinusoid option, which is all the way to the left. Okay, guys. So welcome back. As you can see here, we're zoomed in onto our box here. So you might see a lot going on right now. Don't worry. This first half right here, don't worry about this part of the circuit right here. This is for experiment 3 actually, CP later on. So actually we're going to worry about this bottom half of our board right here, okay? Now you can see here I already have a few components actually in here, but I'll explain every component that we need for this experiment, and then we'll start working with it, okay? So the first off that we do need is our DC source, which is right, show you right here. Is right here with our 9-volt battery, okay? This is what we're using for our DC voltage source, like we said earlier, 9 volts. Then next in series with that is actually our function generator, which actually is going to be connected right here. This is our positive side of our function generator right here. Okay, so this black, the black knob right here. This is what we'll be using as well as a ground. It's pronounced GND. This is the abbreviated version of it. This is going to be our ground. Make sure your circuits are always grounded, so that way first they work and that you don't cause any danger to yourself. Okay. These right here are our resistors. So what we did was here is that we do require 400 ohms of resistance, right? Well, we don't have a 400 ohm resistor available actually. So what we did is to equal be as close as possible, which is like a smooth curve. This right here is actually your frequency. You see we have from 1 to 10 kilohertz. Okay. You're going to play with this a lot. Like we said earlier, you're going to need your hertz to be in the higher range to actually hear the sound coming out from the speaker. Okay. Then actually right here, you have the amplitude as well for your frequency to see how that changes as well. We'll play with that a little bit. Okay. So now what we're going to do here is all you need to do is just shine your light here onto your solar cell, right? And again, what this is doing is that it is actually sending photon and its energy into the solar cell and creating a voltage. And you should be able to hear it. I'll be quiet. Probably better if you're working in 2s or 3s to have one person hold up the panel and one person mess with the knobs and listen for the sound being created. So I hope you guys can hear it. But Brandon's messing with the knobs here. He's actually changing frequency, and you can actually hear how it changes, and that means that you're hearing the function generator, emitting a sinusoid and the solar cell capturing the energy.
So guys, go ahead, take a few minutes and play around with this circuit. We want you to change frequencies and see what you hear the higher your frequency goes. Right now we've got it at probably right at around 6 kilohertz, and we can have a good sound coming out of it. There isn't much else we can do because this is a real simple basic circuit with absolutely no amplification. And we're going to circle back around to that here in just a little bit for our experiment 3.
Of course. So guys, again, very easy. Thanks for watching, of course. We'll come back to you for our closing in a second. But again, it's very easy to follow. And if you have any questions, please refer to the lab manual, or you could just comment below if you have any questions. we'll definitely answer them as soon as possible. Okay, so we again right back to our closing. Hope you guys have a lot of fun with this. All right, guys. So I hope you had a lot of fun with that one. Like I said, it is a little hard to hear because the sound is very soft. So please be mindful of the people working next to you and just listen. And it is pretty cool stuff. And again, if you have any questions, you can always refer to the lab manual that you have, or you can always ask us. Comment below. We'll be sure to get back to you ASAP. But yeah, experiment 2. That's experiment 2. Wraps it up. And what's going to be real cool is that for the next experiment that we will show you guys after is that we're going to actually combine experiment 1 and experiment 2 together. Okay, so that way you can have.
Should we have waited to surprise them with that though, instead of like spoiling it? You're the type of guy that goes to the movies and has watched the spoilers before you get there.
I get so excited. Okay, I watch every trailer and everything. Okay, I get so excited. I can't wait. Sorry.
It's spoiling it for y'all guys. So now you know what's coming up. But
yeah, but you don't know how well it's gonna act. Okay, so you'll still be surprised. I promise. Okay. But again, thanks again for watching. Please comment, like our video, share with your friends.
Subscribe to our channel, please.
Definitely.
We take donations.
Right. Always you want to. No pressure.
Please.
But also, enjoy yourselves and be careful. Again, safety is always priority. Make sure that you're not messing with anything that you shouldn't be able to, or if you're not sure if something will break a knot if you do it, just don't do it. Okay. Just stay within the parameters of the experiment and have a lot of fun with it, and you'll be just fine. Okay? But
yep. Safety first, guys.
Of course. But until next time, hope to see you again, experiment 3. Hope you're enjoying it so far, and I can't wait.
Yep.
So, see you guys. Have fun.